Okay, let's just take a look at this important announcement. The project is due on Tuesday, the 6th of November. And so, just as a review, I've given you some questions that you should solve on paper, the getting started questions. And once you have those equations solved on paper, then you transfer it into a spreadsheet, and you can begin to address the main driving question of the project itself. So if you have questions about the project, I'd be happy to take a look at what you've done. Feel free to stop by my office, or if you run into trouble over the weekend, you can send me an email. I'm going to be out of town, so I won't have access to all of my files, and so if you do send me a question, it would be best if you provide as much detail as possible so I can try and figure it out that way. What we're going to do today is continue the in-class exercise 21, where we were doing price, demand, and break-even, and then we're going to be talking about a different kind of break-even, which is break-even between two alternatives. All right, so just to refresh our memory on the in-class exercise that we were just finishing up from last time, we have a company where they are producing an electronic timing switch, and they have two different costs associated with that timing switch. They have fixed costs of $73,000 a month, and so fixed costs, recall, those are things related to rent or insurance or the capital recovery costs of the equipment that they own. So those are things that are unaffected by the level of production. That's the definition of a fixed cost, is something where the amount stays the same regardless of how much you make. The variable cost is $83 per unit. So that means that they have components and materials that go into making this electronic timing switch that cost them $83 per unit. So you can find what is their total cost by adding the fixed cost and the variable cost per unit multiplied by the number of units produced. Now, the selling price relationship is defined by the curve price is 180 minus 0.02 times demand. And this price-demand relationship is what gave us that curve, and it can be a line and still be a curve, but that relationship that says if you have an increasing price, there's lower demand, and as demand goes up, the only way to make that happen is by lowering price. So this step A, B, C, D kind of takes you through all of the steps required to visualize this same curve. In the end, what we're going to do on Excel is create the same curve that shows the fixed cost, the total cost, the curve of revenue that goes up till a certain point, and then the point of maximum revenue is associated with D hat. Remember the formula that we saw for D hat. I'll bring it back up on the screen in just a minute. But then the revenue is declining again because of lowered prices that were required to stimulate demand. And then the break-even points is those points where the cost and the revenue are equal. And so there are two of them, 2 points where you have a low production break-even point, a high production break-even point. So in our case, here are the formulas that allow you to calculate optimal demand and those break-even points. Okay, so I'm going to pause and give you some time to finish working on that in-class exercise. Okay, I'm going to start going through the solution on the screen because we kind of have to keep moving. In problems like this, you'll be given a statement that defines the price-demand relationship. And remember, it's the intercept that is A and the slope of that curve that is B. And so A is 180, B is 0.02. We also have the fixed cost, so that's capital CF, and then the variable cost per unit, and that's a lowercase CV. The total variable costs will be the variable cost per unit multiplied by the number of units. So here you can see the substitution for optimal demand, and as I was walking around, it seemed like everybody's on the right track there, that the optimal demand is 2425 units. So what that means is, that is how many units the company should make to maximize profits. If they make more than that, or if they make less than that, they're not going to maximize their profits. And where this comes from is that analysis of the slopes that we were going through on Tuesday. When I was saying, as the profit and as the cost and revenue curves are getting further apart, then the profits are still increasing. And so you want to maximize how far apart those two are. And that's when the two curves are parallel. So 2425 units is how many of these timing switches the company should make. Now, max profit is going to be revenue minus costs. One of the ways to find out your revenue is just how many units are sold multiplied by the selling price. And so we know that it's 2425 units. That's the number of units we should sell to maximize our profits. So 2425. And then what price is that? So we put that into this 180 minus 0.02 times D. And so the price is going to be 180 minus 0.02 times 2425. This equation that I've got on the screen basically combines those two together. Price times demand. And did anybody else in here get 318,887 for the revenue? Okay. Now the costs, we do a similar thing. We add the fixed costs and the variable costs. And the variable costs are going to be the variable cost per unit multiplied by the number of units sold. So now the difference between the two, the difference between the revenue and the cost, is our profit. And why am I calling it the max profit? It's because this is the profit that's associated with optimal demand. And we could try other amounts. We could try, what if they sold 1,500? Or what if they sold 3,000? Any other number besides this is going to have less profit than the one that we've just found. Any questions so far? Okay, now break even is where we have to substitute into this lengthy equation here. And so the formula is going to require us to have A, which is the intercept of the price-demand relationship, C sub V, which is the variable cost per unit, and then also the slope of the price-demand relationship goes in there as B, and then the fixed costs. So I solved this in a couple of different steps just so that it's easier for me to check my work rather than just putting in my calculator and hoping I didn't miss something. I do this part before the plus and minus, so that's minus 97, and then plus or minus, and so everything that's inside of those brackets works out to 59.4, and then dividing by negative 0.04. So the two break-even points are 3918 units and 932 units. So if you find out the selling price and the amount of revenue, and then you also calculate the costs associated with these, then you would find that there's no profit at either one of these. So the range of profitable demand. Now this is a really important point because you may see that phrase in homework problems or quizzes or exams. The question could be asked, what's the range of profitable demand? And so you have to sell at least 932 and up until 3918. But any more or less than that, and the company would be losing money. Does that make sense to everyone? And then if you just sketch it out, here's what the curve is going to look like. And that's not my best artistic efforts, but the key points here is we have our optimal demand identified, D star is 2425. We have the revenue curve, and the cost curve that starts with the fixed cost over at the intercept with the vertical axis, and then it's a linear increase because the variable cost per units are causing it to go up. And so then the range of profitable demand is from 392 until 3918. And so that's these crossover points between the cost curve and the revenue curve. Oh, you're right. Yeah, that says 392. I got a little dyslexic there. 932. Thank you. I'll fix that. All right, so let me zoom out in case there was anything else you needed to copy down for this one before we move on. Does anybody need to see this any longer? Everybody's got it? Okay. All right, well, let's move on to a different type of break-even. You know, here, the break-even that we were talking about was in terms of a single company and a product they're making. The break-even points between the production costs and the revenue that's coming in. Another way of looking at break-even is break-even between alternatives. And let's begin by going over some important terminology in economics. And for those of you who've already taken like a macroeconomics course before, then you maybe have heard some of these terms. Perfect competition is defined as an environment where there's a lot of people supplying a particular thing, and there's no restrictions on new suppliers entering the market. And so an example of perfect competition might be for laptop computers, because there's so many different producers of laptop computers, and it seems like there isn't much of a barrier to entry in the market. So it's a very competitive market with very thin margins. Like the companies are kind of really cutthroat in their competition trying to get an edge. On the other end of the spectrum are situations where you can really only buy the thing from one company or from one entity. And so it's a unique product or service that's only provided by a single supplier, and no other people can enter the market. And so an instance of a monopoly would be water at your house. If you're receiving water from the water company, West Virginia American Water, you have no choice but to buy your water from them at whatever price they can convince the Public Service Commission to allow them to charge. So there isn't any competition for things like water services or electricity. And part of the reason for that is that the infrastructure costs associated with delivering those goods or services to a home are so high that it wouldn't make sense to have more than one set of pipes coming through a neighborhood. It wouldn't make sense to have different sewer systems, and then whoever's charging the least for sewer, you send your wastewater into their sewer. That wouldn't be practical. And so there are certain things that are allowed to be monopolies, and in theory their prices are supposed to be regulated. So that's at the wild end of the spectrum, is environments where eBay is an example of a really efficient market, where there are literally thousands, if not tens of thousands of suppliers. If you want to buy a cell phone case, you can go to eBay, and there are people who will ship it to you from China. There are people selling the item from Hong Kong, Taiwan. It seems like a lot of the really inexpensive items are shipped directly from Asia. Although it takes a little bit of time before you to get it, the prices are really low because there are so many different suppliers. Now, true monopolies are rare because oftentimes there are substitutes for the things that are supplied. And so, if bread prices get really high, people can eat rice instead. And so substitutions, like in terms of transportation, if somehow the automobile manufacturers were able to form they work on collusion and raise their prices really high, then maybe people would ride bicycles for transportation. Or maybe other means of transportation would be used as a substitution. And regulations are supposed to control the prices that monopolies charge. And so they can't really exploit to the maximum way that they could if there was no regulation at all. So here's a picture of a worker packaging Twinkies, putting it in a box. You know, for a while, it was looking like the company that owned the trademark for Twinkies was going out of business. And I think that there was a couple of weeks where no Twinkies were going out into the world, and then that was a dark day for sure. But let's use that as an example to talk about the different types of costs that I've already hinted at. And so remember, we've talked about fixed costs. So fixed costs are defined as the expenses that don't change as an amount of production. And so in the case of this picture here, the fixed costs would be the machines that we see in the background, because even if those machines aren't running, the company still had to buy them, and they still needed to be there. The heating and cooling costs for the building may be fixed, because if the thermostat is set to 72, then it may kick on whether or not anyone is in the warehouse, and maybe it kicks on more frequently if the machines are running. That could be argued. But a lot of times, other expenses like insurance are considered fixed costs, because you have to continue to pay the insurance regardless of whether or not you're making 100 Twinkies a month or 1,000,000 Twinkies per month. So that's fixed costs. Here's a list that the book mentions as typical fixed costs. Variable costs are those that are affected by how much of the item is being made. And so it's not only the materials like the plastic wrapping, the flour, the sugar, the vegetable oils, and so on. It's not just the cost of the materials, but the shipping costs, the cost of the workers, you know, that hourly labor expense is considered a variable cost. Warranty costs are variable, because the more items you put out into the world, the more money you have to hold in reserve to cover the cost of any potential replacements that have to be given to customers. Now, regarding labor, why do you suppose salaried employees is listed as a fixed cost, whereas hourly labor expenses are a variable cost? Okay. Well, what if they do know? What if it's $15 an hour? So it's not necessarily whether or not they know.
They don't know how many hours you're going to work.
Okay. So the salaried employees get their wages regardless of whether or not the assembly line is working at full capacity or half capacity. The definition of a salaried employee is someone who receives their wages on kind of a 2-week basis or a monthly basis, and it's not necessarily by the number of hours they're there. That's why there was a lot of news recently about like McDonald's managers, and they make a really poor wage because they're expected to be in the store so many hours per month that for many of them they'd be better off if they were the hourly employees. All right, so we've seen this before, the cost relationship between the units of production and cost. And remember that the total cost is the variable and fixed together. Now, there can be nonlinear cost relationships. And think about, what is this nonlinearity implying? Since the curve is getting less steep, then that means that as you sell more units per year, that your variable cost per unit is decreasing. So this curve is flattening out, and that means that you're making more and more, but the cost isn't going up as much as it used to for the same incremental additional number of units. So can you think of like what would cause the curve to flatten out like that? Exactly right. So think about bulk discounts. In the case of the Twinkies, maybe if they buy 1,000 pounds of flour per day, they have to pay $1 a bag. But then if they buy 10,000 pounds of flour, they're getting a bulk discount, and so their variable costs per unit are decreasing. So that's an example of how you could potentially have a nonlinearity in cost. Now, if we zoom in on the break-even point, this is what we see. The fixed costs mean that even if you're making 0 units per month, you have some costs. So the intercept with the vertical axis, this point right here is associated with the fixed costs. And hopefully, if you're operating a company, what happens is that your revenue is going up, and at a certain point there's a crossover there, so that your revenue begins to be higher than your cost line. And so to the right of that first break-even point is where you're now in the profitable range. So revenue is the number of items sold multiplied by the sales price, and that's just what you did in the in-class exercise that we've been working on. What's going on here is that now finally the revenue exceeds the costs. Now think about what happens if you're a supplier and this was your original curve that shows revenue and costs. What if your costs go down? And so if your variable cost per unit decreases, like if your cost line gets flatter because your costs have decreased, then that's going to change the break-even point. And that's what this illustrates. So this was the first cost curve, but then somehow this manufacturer renegotiated their costs, and they got their variable cost per unit to decrease. And so now there's this blue curve is the total costs with lowered variable costs. So their fixed costs stayed the same, but somehow they brought their variable costs lower, so it shifts the break-even point to the left. Remember, anytime you see a figure like this, it should perk up your ears, because this could be a figure that you have to explain on a quiz or an exam, or it's something you maybe would have to sketch and explain. And so the concept here is a reduction in variable costs moves the break-even point to the left. So it means you have to sell fewer items to break even. If your costs are lower, you don't have to sell as many things before you begin to get into the profitable territory.
There's only one break-even point on that graph, right? Like it'll only be one.
Well, you're either going to have the higher costs or the lower costs. And so this is kind of like before and after. And so there's only a single break-even point because we're just zoomed in on the left side of that larger curve. You remember the sketch that I showed before with, let me go up to this one. What we're doing is we're basically zooming in on the first break-even point right there. So there still is a second break-even point. It's just that we're not zoomed in, we're not zoomed out far enough to see it. So the cost curve is lower when variable costs are reduced, and therefore the break-even point moves to the left, meaning fewer number of units required before you get into the profit. Now, two alternatives. Let's look at these two different options. There's the first option and the second option. Alternative 1 has a lower fixed cost. That's what this intercept with the vertical axis, remember, is the fixed costs. So if you buy a certain item, then you're producing your things with it. This has lower fixed costs, but option 2 has higher fixed costs but lower variable costs. So the question is, should you buy equipment 1 or equipment 2? And what this graph shows is it depends on how many items you're going to be manufacturing. So if you're going to be manufacturing, what you want to do is you want to minimize your costs. If you're going to be manufacturing a relatively small number of units each month, then you should choose alternative 1. Now, a good illustration of what these might be in like a physical sense would be an inkjet printer versus a laser printer. Everybody knows what those two things are, right? And you could walk into Walmart and get an inkjet printer for like $10 sometimes, like Black Friday prices, you know. If you spend all night waiting in line, you can go get an inkjet printer for $10. They're really cheap. How did the companies that make an inkjet printer, how do they try and get you though? The ink cartridges are really expensive. Like you can get the printer for $10, but then the cartridges are like $35 or $40. And so if you own an inkjet printer, they're cheap to get in the first place, but the per page cost is really high because the ink is expensive. So that's an example of this alternative one. It's cheap to get the equipment, but then the variable cost per unit, meaning like the ink costs, are high, so it's steep. Now a laser printer, by contrast, it's expensive to buy. That first cost, you know, maybe you're going to spend $80 or $90 for the laser printer, but that the ink is a lot cheaper. So the variable costs are less. So whether you should get the inkjet or the laser is dependent on how much printing do you expect to do. If you're just going to be printing 1 or 2 pages a month, then it doesn't matter if the variable cost per unit is a little bit higher because you're saving so much money on the first cost that you're better off on the left side of this, you know, on the low number of pages printed, you're better off getting alternative one. But if you're going to be printing a lot, then that reduced cost per page more than covers the increase in the fixed cost. So the summary is that which alternative to select determines the level of production. So if you choose option 1, then you may not be able to be profitable in situations where option 2 could be profitable. So here, what we're saying the break-even point is it's the point at which both of the alternatives have the same cost. All right, so I have a new in-class exercise for you. And what we're going to do with this one is we will be using Excel. On the back side of the paper is a template that you can use to set this one up. So we're going to compare 2 different options. Okay, a company is either going to have equipment that's computer controlled or controlled manually. The computer controlled equipment is more expensive as a first cost, $2 million. It's going to last for 7 years. We see it has a salvage value, certain labor costs, an output, meaning the number of units per hour it can make. In option 2, it's cheaper as a first cost, but it can't make as many units per hour, and it has higher labor costs. So those are some of the significant differences. On the back side of the paper, I give you the template, and so you're going to have to calculate in part A the capital recovery for both alternatives. Do you remember what is the definition of capital recovery? No, that's not quite it. Good, right. So what she said is it's you're annualizing 2 things. There's the first cost for the item, so you've got some present value, and then there's the salvage, which is an inflow. And so what we're doing, 1, 2, 3, 4, up to n, is we want to find out what's the annual equivalent of a first cost and the salvage value. And so you can use the PMT function for that one. So part A is you're finding the capital recovery based on the first cost and the salvage. Compare those two. And then what I'd like you to do is analyze for a certain number of units per year what happens. Like what's the cost of each alternative? And we're just only going to be looking at costs for these. We're not going to be looking at the at the revenue that comes in for what's being made. We're just going to try and find out at what point do the costs break even. So if we make 1,000 per year, which option is better? Option 2 is better because the costs are lower. And I did the conditional format to make it bold, whichever one is better. And just a refresher on the conditional format, you highlight 2 cells, and we'll do conditional formatting. Let's clear the old rule. All right, so home, conditional formatting, new rule. What I want it to do is format only the top ranked value. So the top one value should be bold. So the one that's the biggest will be bolded. And why is it good to have the big numbers? Because these are negative numbers. And so whatever's least negative is the lower cost. So option 2 is better at 1,000, but what if I make 3,000? Is the other option, yeah, 3,000 per year. So I'll change that. $3,000 per year, then option 2 is better. It has the lower costs. And here you can see I've calculated the difference in cost between the two. So now at 3,000 units per year, even though option 2 costs more to get off the ground, it has a higher first cost, that lower labor cost and the improved productivity makes it a better choice. Now, how have we handled the fact that it's a different number of years? It's because we've annualized the cost. And remember, anytime you do an annual worth analysis, you're automatically assuming the LCM approach. It's built in to annual worth analysis, that assumption. So it's okay for us to do this comparison of the different number of years because this is all on an annual basis. And what we find is that on an annual basis, option 2 is better. So then the final thing, to find the break-even point in part D, what I'm going to do is home, data, what if analysis, goal seek. And my goal is for the difference between the two to be 0 by changing the expected output. So it goes through, tries a few different numbers, and it's 2046, so 2046. You can't make a fraction of a unit. So 2046 is the closest. It's pretty close to 0 for the difference, but what it shows is that they're essentially the same cost when you're making about 2046. And so what we'd say is that if you're making fewer than 2046, then which one is better? So if we make 1,000, option 2 is better. 2045, option 2 is better. But what about 2047? Option 1. And so anything 2046 and greater, option 1 prevails. Less, option 2. Okay, that's all I have for you today. If you finish this, you're welcome to leave. If you want to continue to work on it, I'll stick around for a few minutes and answer questions. Please remember that next time we meet, you're going to be done with the project. So the project is due on Tuesday, November 6th. You need to upload all of your items to MU Online before 8 a.m. on that date. Let me know if you have any questions on the project. All right. Have a good day. I'll stick around and leave this spreadsheet up on the screen in case you need to continue working on it.